Good morning, everyone. Today, the topic is infrared spectroscopy. It is also known as vibrational and rotational spectroscopy. It is a type of absorption spectroscopy used to determine the functional group of a compound. IR spectrum of a molecule, also called vibrational spectrum, due to transmission of molecule vibrational energy level to the other. IR spectrum of a molecule is obtained from transition between vibrational and rotational energy levels, hence called vibrational rotational spectroscopy. Infrared region of a spectrum is having the range from 12,500 to 50 centimeter inverse. It is divided into three parts: near IR region, far IR region, middle IR region. Near IR region is having the range from 12,500 to 4,000. Middle IR region is having the range from 4,000 to 667 centimeter inverse, whereas last one, far IR region, that is having the range from 667 to 50 centimeter inverse. Whereas this middle IR region is the important region. It is again divided into two parts: 4,000 centimeter inverse to 1400 centimeter inverse. That range is known as a functional group region, whereas 14,000 centimeter inverse, 1400 centimeter inverse to 667 centimeter inverse is known as a fingerprint region. It is the range of IR radiation. Coming to the principle involved in the IR radiation. In case of IR radiation, molecular vibrations will take place. That is only the principle involved in it. Coming to the molecular vibrations, in general, a molecule may be regarded as a system of ball and springs. When it absorbs IR radiation, it vibrates in excitation of bond deformation. The bond deformation may be stretching and bending. Coming to this molecular vibrations, these molecular vibrations are two types: stretching vibrations and bending vibrations. Okay, stretching vibrations again divided into two types: symmetrical stretching and asymmetrical stretching. Whereas bending vibrations are divided into two types: in-plane bending, out-plane bending. In case of in-plane bending, there are two types of bendings: scissoring and rocking, whereas out-plane bending, wagging and twisting. So first we will discuss about the stretching vibrations. So stretching vibrations, this type of vibrations arise because of stretching and contrasting of bonds without change in bond angles and a change in bond length. Here the bond angle remains same, bond length varies. Two types of stretching vibrations are there: symmetric stretching and asymmetric stretching. Coming to symmetric stretching. In this type of stretching, the movement of atoms occurs in the same direction with respect to the central atom in a molecule. This is the central atom, and the two atoms attached to it will be stretching in the same direction. Coming to the next one, asymmetric stretching. In case of asymmetric stretching, in this type of stretching, one atom move towards the central atom like this, and other moves away from the central atom. One is coming towards the central atom, one is moving away from the central atom. This type of stretching, we are calling it as a asymmetric stretching. Coming to the second type of molecular vibrations, that is bending vibrations. Here in-plane vibration, when in-plane vibrations or there, out-plane vibrations, that means bending or there. In case of in-plane bending, first we will see the scissoring. In this type of vibration, the two atoms approach to each other in the same plane. So both the atoms will be in the same plane. They will be acting like as a scissor moves. In the same manner, the two atoms will also move in opposite direction. Next comes the second one, rocking. In this type of vibration, the molecule, the movement of atoms in the same direction. The atoms are moving in the same direction, in the same plane itself. This is known as a rocking vibration. Just like a rocking chair, how it will be moving in the same manner, they will also move in the same direction. Next comes second one in the bending vibrations, out plane bending. In case of out plane bending, two types of bendings are there, wagging and twisting. Coming to the wagging, in this type, the two atoms move up and below the plane with respect to the central atom. So one is moving above the plane, one is moving below the plane, like this as shown in the diagram. So next comes the second one, twisting. So in this type, one of the atom moves up to the plane and other moves down to the plane with respect to the central atom. This type of bendings are known as a twisting. In general, if you take these IR spectroscopy, whatever the polar molecules are there, that molecules only IR active molecules such as HCl and CO, whereas non-polar molecules are IR inactive like N2 and H2. So, but CO2 is non-polar, but it is IR active. This is due to the fact that in asymmetric stretching of CO2, there occurs a change of dipole momentum and it becomes active. Next comes the applications of IR spectroscopy. Okay, before that, so we can also discuss that calculation of fundamental vibrational modes for each and every molecule. First, suppose particular molecule is a vibrational stretching. If it is a linear, then the formula will be 3n minus 5. If the molecule is a non-linear, the formula is 3n minus 6. For example, C6H6, we can take C6H6 is a non-linear molecule. It is having the 12 atoms. So we can apply the formula 3n minus 6. In place of n, we will substitute 12. Altogether, if you calculate that one, we will get 30. That indicates 30 molecular vibrations are possible. Next comes, like that we can calculate for other molecules also. If it is, we will check that it is linear or non-linear. We will apply the formula according to that. Next comes applications of IR spectroscopy. It is widely used to detect functional groups in a molecule. It is used to study of covalent bonds in a molecule. In biology, IR spectroscopy is most commonly employed to qualitative secondary structure or to determine the change in the structures. Next one, a potential tool to discriminate between a set of geometrical isomers in many cases, just like cis and trans isomers, to identify hydrogen bonding in a molecule, and then detection of impurities in a compound. It is used to structure elucidation of organic compounds, determination of impurities in a molecule. It is also employed for rapid quantitative analysis of mixture of compound and in pollution detection and in milk analysis. These are all the applications of some of the applications of IR spectroscopy. Thank you, everyone.